Your system is up. Dashboards are green. CPU is fine. Databases are running. And yet, some users are seeing old data. Others can't save anything. Some requests succeed. Some don't. Nothing is down. Nothing is crashed. This is the most dangerous kind of failure in distributed systems. And if you've ever shipped a system at scale, you will see it. What's happening isn't random. It isn't a bug. And it isn't bad luck. It's the result of a trade-off you already made, probably without realizing it. This is where CAP Theorem actually lives. Not in textbooks, not in interviews, but in incidents. Distributed systems make choices. During partitions, you can't have everything. You can choose CP, correctness first. You can choose AP, always respond. Or CA, correctness and availability, if partitions never happen. Most systems can't do CA. It's theoretical. CAP theorem is often taught as theory, but here's the only part that matters. When a distributed system experiences a network partition, you must choose between consistency and availability. Partition tolerance isn't optional. If your system is distributed, partitions will happen. So the real question is, what do you do when the network lies to you? Choosing consistency means every read sees the latest successful write. No stale data, no conflicting views. To do that, systems coordinate. Leaders, quorums, synchronous acknowledgements. The data stays correct. But when coordination fails, the system stops serving some requests. Writes get slower. Reads may block. Errors show up. Consistency buys correctness. And it charges you in availability. Availability means the system always responds, even during failures. That response might not be correct. It might not be up to date. But it doesn't block. Internally, this means local writes, asynchronous replication, and resolving conflicts later. Users stay happy. Traffic keeps flowing. But correctness is no longer guaranteed right now. Availability buys responsiveness, and it charges you in certainty. Network partitions aren't rare edge cases. Cross-region traffic, cloud networking, packet loss, timeouts that lie. If your system is distributed, partitions aren't a question of if, but when. And when they happen, CAP forces a decision. Imagine an online store during a flash sale. Inventory is spread across regions. A partition hits. If the system favors consistency, checkouts may be blocked. Users see errors, but inventory stays correct. If the system favors availability, checkouts continue. But now you might sell items you don't actually have. Here's how the wrong inventory actually happens. Nothing explodes. Nothing crashes. Every service does exactly what it was designed to do. The problem is that they're no longer agreeing. Inventory lives in multiple partitions, multiple regions, multiple replicas. Each one believes it is correct, because locally it is. But during a partition, those replicas stop talking to each other. One partition says, "We have 5 items left." Another says, "We have 4. Both are answering real user requests. Both are accepting writes. Both are technically healthy. Same product. Different answers. Now traffic spikes. Users are checking out fast. Each region decrements its own count. No coordination, no global lock, no waiting. From the system's point of view, everything is working. From reality's point of view, you just sold item number 6. And here's the dangerous part. The error isn't immediate. The checkout succeeds. The confirmation email is sent. The payment is authorized. The lie only reveals itself later, when fulfillment can't find the item. Now the system has choices to make. Do you partially fulfill the order? Do you cancel it? Do you delay and hope inventory reconciles? None of these are technical problems anymore. They're business problems. And they were created by a technical choice. Eventually, the partition heals. Replicas sync. Counts reconcile. The system realizes the truth. But by then, customers already experience the lie. This is why availability-first systems feel fine. Until they don't. They push inconsistency downstream, into refunds, into support tickets, into manual cleanup work. The system stayed up, but trust quietly leaked out. Wrong inventory isn't a bug, it's delayed truth. And delayed truth is the price you pay for never saying no during failure. Both choices are rational, and both have real consequences. CAP decisions don't disappear, they just move the pain. Consistency-first systems pay up front. Blocked requests and visible errors. Availability-first systems pay later, like reconciliation, retries, data repair. You either absorb the cost now, or you absorb it downstream. Real systems don't choose one CAP mode for everything. Payments favor consistency. A double charge is unacceptable. A missing payment is catastrophic. Feeds favor availability. Seeing one post twice is better than seeing nothing at all. Caches behave differently than databases. They're allowed to lie briefly. Databases are not. Good system design is deciding where inconsistency is acceptable and where it isn't, because not all data is equal. And not all mistakes cost the same. That decision should be intentional, not accidental. One of the biggest mistakes teams make is treating CAP as theoretical. CAP shows up during incidents, partial outages, peak traffic. If you haven't discussed how your system behaves during partitions, you've already made the decision. You just don't know which one. CAP Theorem doesn't tell you how to design your system. It tells you what you're trading away. Consistency buys correctness. Availability buys responsiveness. Great systems aren't perfect. They're intentional. Distributed systems don't fail randomly, they fail according to the choices we make.